In the previous section, we saw how to plot linear polynomials and also how to find zeros of linear polynomial. In this section, our focus will be on quadratic polynomials. We will see the plot of quadratic polynomials and we will also see how to find zeros of quadratic polynomial. We will take that concept a bit forward and try to gain some insights about higher degree polynomials such as cubic polynomials. So let's get started. The general form of a quadratic polynomial is ax squared plus bx plus c. Let's say we want to plot the quadratic polynomial p of x equals 2x squared minus 2x minus 12. And how do we plot this? All we have to do here is to take some random values of x and find the corresponding values of p of x. Once you have values of x and p of x, you will be easily able to plot these on a graph paper and see how the graph is shaping up. So let's draw our table and take few values. Now remember, in the previous section, we only took 2 or 3 values. For a line, that's okay because all you need to draw a line is just 2 points. But for a quadratic polynomial, you need more values to see how the graph is shaping up. So to plot this quadratic polynomials, let's take integer values of x from minus 4 to 4. And then find the corresponding values of p of x. And here is your results. As usual, let's plot these points one by one. When x equals minus 4, the value of y is 28. So the point is here. When x is minus 3, the value of y is 12 and that point is here. Let's continue this process till we plot all the points in the table. After plotting all these points on the graph, let's connect these together. So what do we get? We get a U-shaped curve. This is known as a parabola. In fact, you try to plot any quadratic polynomial, what you get is a parabola. Now in this case, we got a parabola that is open upwards. Now for some other quadratic polynomials, you may get a parabola which is open downwards. So you can have a upward open parabola or downward open parabola. Alright, so here we have the graph of quadratic polynomial 2x squared minus 2x minus 12. Now looking at the graph, can you spot zeros of this polynomial? Now zeros of the polynomial are that values of x at which p of x becomes 0. For our learnings from the previous section, we can easily locate zeros of the polynomial by looking at the graph and locating the points through which the graph intersects the x-axis. We can clearly see that the parabola intersects the x-axis at 2 distinct points. One is x equals minus 2 and other is x equals 3, which means there are 2 zeros for this quadratic polynomials, and that is x equals minus 2 and x equals 3. In the case of a linear polynomial, we saw that there is only 1 zero, and that is always true. A linear polynomial will always have 1 zero. The quadratic polynomial example that we just saw had 2 zeros. Does that mean that a quadratic polynomial will always have 2 zeros? Think about it. Now we have seen that a quadratic polynomial will always result in a parabola, right? Now I can have a parabola like this or this. In both these cases, we can clearly see that the parabola intersects x-axis on 2 distinct points. In such a case, we can say that there will be 2 zeros for that particular quadratic polynomial. Now consider this parabola. We can obtain such a parabola also for some quadratic polynomial. Now consider these two cases. Looking at the parabola, you can easily see that this parabola intersects the x-axis at only a single point, which means there will only be a single zero for these quadratic polynomials. Now consider these cases. Now do you think this parabola will ever cross x-axis? Not really. So in this case, we say that there are no zeros for such quadratic polynomials. So what does this mean? It means that a quadratic polynomial can have no zeros at all, it can have a single zero, or it can have two zeros. At the maximum, a quadratic polynomial can only have two zeros. So that's all about plotting quadratic polynomials and interpreting zeros of quadratic polynomials. In the next section, we will discuss how to plot cubic polynomials and interpret zeros of it. And we will also see few examples. Now this same process can be extended to any higher degree polynomials. If you are given the plot of any random polynomial, you can look at the graph and locate zeros of that polynomial. All you have to do is to look at the x-coordinates of those points at which the graph intersects the x-axis. Let's seal this concept by doing this one last example. Let's try to find zeros of a cubic polynomial. Consider the cubic polynomial x cubed minus 3x squared minus 3x plus 3. Now that you are familiar with plotting the graphs, I would encourage you to plot this graph yourself. When you do that, you will get something like this. You can clearly see that the graph intersects x-axis at three distinct points. X equal to minus 1, x equal to 1 and x equal to 3. So we say that this cubic polynomial will have 3 zeros. Now does that mean that a cubic polynomial will always have 3 zeros? Not really. If you try to plot a cubic polynomial, for example x cubed minus 3x squared plus 3x minus 1, you will get a plot like this. You can clearly see that the graph passes the x-axis at only one point, that is x equal to 1. So we say that this cubic polynomial has only one zero, that is x equal to 1. So a cubic polynomial can have at the most 3 zeros. In general, any polynomial of degree n could have at the most n zeros. So let's quickly summarize the learnings from this chapter. If you are given the plot of any random polynomial, you can always find zeros of that polynomial. How do you do that? All you have to do is to look at the x-coordinates of the points at which the graph intersects the x-axis. Those points would be zeros of that polynomial. Now before you move on to the next section, I would encourage you to try your hands on these examples given to you. All you have to do here is to look at the plot and find zeros of these polynomials. Make sure to cross-check your answer with the answer given in the video. If you have any doubts, feel free to use the doubt section, post it there, we will be happy to help you.